Jumping to this next slide here, so our 3DCS scalable solutions, this is kind of a Venn diagram of what we have included in all of our softwares here. So if we look at this red circle, DVM, if you're familiar with our VA software or if you've used it before, these are icons in our software, which I'll show in our demo pretty soon here. So with our DVM, if you're familiar with VA, you might recognize that move icon right there. That's our feature move icon. So in DVM, there's not going to be any points. It's all feature based. So all of our moves, GD&T measures, they're all only using the features. You're not going to be able to create points anywhere. So that's where you will see the points icon in MVM and in VA, and not in DVM. We also have GD&T still, but you can also see we don't have form. We only have location and orientation in DVM. So back over here, we have two types of measures in DVM, which I'll talk about in the demo also. But just to give a quick overview of those right now, we have a dimensioning location measure and a GD&T measure, which are fairly new for VA also. So they were actually released in the 7700 release of our software. So you may not be familiar with those if you've ever used VA again. But I'll cover the dimensioning location measure. The GD&T measure is going to be covered in a future webinar, so I'm not going to talk too much about that. And then just like VA and MVM, we still have the nominal build, animate, and deviate buttons. We have slightly different of a analysis button there. So as you can see over here in MVM, we're using a Monte Carlo analysis with the bars there. And then in DVM, we're actually just using equation-based analysis. So I'll talk a little bit more about that in the demo itself. So for this demo, we're going to be covering actually two models. This first one over here is going to be the mechanical transfer switch assembly. It's just 3 parts, and we're going to be looking at the moves used to build that, a few measures, and some GD&T there, and then the analysis. The right model here is the pulley model. So that's more of a mechanical, well, not mechanical, I guess. It's that's the model we're going to be extracting joints and constraints from. So this is still used in DVM. We're going to be pulling the CATIA constraints out of CATIA and into our 3DCS model, and we're going to automatically create moves from that. And then same with the measures and GD&T and CATIA. We're going to pull that straight out into our model. So we're going to go ahead and jump over to the model in CATIA here. So this is our DVM software. So you may recognize some of these symbols like I talked about before if you're familiar with VA. So the main thing here is it's a lot more slimmed down. So we don't have all the symbols that Variation Analyst has. We still have the main symbols like I mentioned before: nominal build, separate, deviate, animate, moves, GD&T measures. We have our update model button over there. We have show mesh, which I'll talk about a little bit more in detail if you have not seen VA before. But the big thing is we don't have show points, like I said. There's no points in DVM, and that's just meant to kind of make it a little bit easier on the user, so you can just use the features to fully build a model a little bit faster than in a VA. So a little bit about this magnetic transfer switch assembly model. We have our salmon colored piece here, which is called our base. We then have our green piece here, which is called our metal insert. And then we have our blue jumper piece over here. So we're going to jump straight into creating some moves here. So like you can see over here, I already have my moves created, but I'm just going to cover just a little bit about those here. So over here on the right, I'm going to click on that move button. And if you're familiar with VA, when you click that move button, you'll know that it asks you, or our software 3DCS asks you where you want to put those moves in your tree over here on the left. As you'll notice here, this just automatically popped up to put in the top assembly. So that is one thing with DVM. You're going to put your moves and your measures only in the top assembly. So that's another way we're kind of simplifying our DVM software as opposed to our VA software. You can only have your moves and measures in the top assembly here. And again, with this drop down, we only are using the feature move in DVM. So that's why we only have just this one option here, just again to simplify the software a little bit, make it a little bit faster and easier to use. So we're going to just take a look here. So this first move I have, bringing the metal insert to the base. This is pretty similar to the feature move in VA. The only real difference is we're only going to be using one object target pair per primary, secondary, and tertiary pairs there. So in VA you can add multiple features. In DVM you're only adding one per box here. I'm going to close out of these here, and we're just going to animate through these moves quickly. So again, our first move is going to bring that metal insert to the base. Our second move is going to be bringing the jumper to the metal insert. And then from here, we can kind of start taking a look at the goals for our model, our GD&T. So our goals would be our measures. So I'm going to jump back to that PowerPoint quickly. I have a slide on our model goals here. So this model is actually used in our tutorial for DVM. So this picture right here is taken right out of that PowerPoint. So the goals of this model is to pretty much find this gap right here. We're going to just kind of track that gap and look at our results there. So we want to see if we can stay within that plus or minus 3 from our nominal of 4. Also look at this 4 plus or minus 2 on the right side of that jumper to the base there. And then these two measures right here, those kind of go along with the GD&T measure, which again is going to be covered in a future webinar, so I'm not going to talk too much about those. We're going to mainly focus on this one right here. So I'm going to jump back to the model here. But before we get to measures, I'm going to talk a little bit about GD&T. If you are familiar with VA, you'll notice that I do have GD&T here, and like I said, we're only having location and orientation in DVM. But the overall creation of GD&T is pretty much the same as VA, but I'm going to cover just a little bit of what our software is doing with the GD&T applied in this model already here. So if you're not familiar with VA at all, and this is your first time seeing any type of 3DCS software, you'll want to listen here, and I'll talk a little bit about it. So over here on the top left, I just clicked on this Show Mesh button, and you'll kind of see this spider webbing effect on the surfaces used in the moves, measures, and GD&T. So I'm going to zoom in a little bit right there. So this surface right here with the spider webbing effect has a surface profile of 1 applied to that already. So what I can do over here is just press this deviate button, and you'll see that mesh is actually moving off of that surface. So what we're doing here is we're actually applying that surface profile to the mesh itself, not the actual surface. So we're varying that mesh, not the nominal CAD. And then also, if I were to nominal build here, in our move metal insert to base there, we're bringing this metal insert and touching it up to this surface that we're talking about here. So if I were to deviate, we can see that green part is actually moving with the mesh itself, not the actual salmon colored base here. So what that's doing is just kind of representing our 1D stack through the base to that metal insert with our surface profile of 1 applied there. And I'll zoom out here and turn that mesh off. Nominal build again and just deviate. So this is kind of just taking a look at all of that GD&T we have applied in our model, which I will cover a little bit of GD&T addition. We're going to be creating a new measure after we take a look at results, just to see how simple it is to add a new measure in here. So I will cover a little bit about that, but for right now, we're just taking a look at what is actually applied so far. And again, we're kind of looking at this gap up here, so we can see how that's changing right now.